I'm on the casing level bring up test of the D150W one chip power amplifier runs by the SAMuC. This is SAMuC version 1, and I'm a little bit disappointed because it's not working as I planned. Let me try to power it on right now, and let's see the response there. There you go. This relays will never power it on the power supply and never connect the speaker. Let's try again. You can see this LED in here. The SAMuC goes into the protect mode, which is there is something wrong. I don't know exactly whether my firmware is a problem. I mean the program maybe not correct, or there is something wrong with this one chip power amplifier here. So I wanted to find it out what's the problem, but first thing first, I need to get hydrated. So I'll just have my water in here. It's getting summer right now, and that is the starting point to debug a kind of problem that I'm facing it right now. I need to find what is the problem. So here's I'm going to debug it based on the logic that when the SAMuC will go in to connect the split power supply, it immediately check the offset voltage to monitor the offset voltage just at the output of this one chip power amplifier. And I also connect my oscilloscope to understand if there is any kind of spike, probably if it is a positive side or negative one. August, oh my god, am I reading it correctly? That is like 21.7 volt. That's the spike. That causes the issue on the power amplifier. Let me see the time, and we got there. And the chains are probably just wow, that is 36 milliseconds. Let's see the real effect on the speaker, the oscilloscope there, and then the millivolt offset. Let's see that. And power on. Wow, it's a big thumb. That's the 330 millivolt over there. So this is really close. Hope that we can see the movement of the speaker when I power it on. 3, 2, 1. Wow, you can see the cone of the speaker. It's really moving. So I got a solution in here based from the oscilloscope capture, and it is causing by this unknown amplifier here, the one chip at D150W. And the quick solution right now is I need to modify the software, the program, to add a delay when the SAMuC will go into supply the split power supply by plus or minus 24 volt, and then I will delay to detect the offset voltage about 100 milliseconds, and I can easily do that on the program by just inserting wait millisecond 100, that is 100 milliseconds, and I'm going to reprogram it adding a 100 millisecond, download the program, and I'm going to get the attachment. 3, 2, 1, program download, easy. Remove the cable and put it back the sensors, and 3, 2, 1. Okay, it can power it right now. No big thumb, no big pop. The cone of the speaker will not move. Success actually. This SAMuC project can demonstrate how to protect the dangerous DC offset voltage coming from this unknown amplifier. As I'm saying that this amplifier build, the one chip amplifier D150W, is a good example, a golden reference to show the bad DC offset and its effect on the speaker, and how the SAMuC can protect the speaker from this bad DC offset voltage. So initially, this is the noise level in my room right now. Play the music.